So today we'll be solving Leetcode May 6th challenge. So let's get into the question. So the question is to remove all the adjacent duplicates in the string 2. Okay. So the question is we have to remove all the adjacent duplicate elements. For example, take this example. They have given us 3. So whenever we see a 3 consecutive elements, we have to remove them. And again, this can be applied recursively. So if you remove this 3 E's, then D and D will also become consecutive, right? That also we have to handle. So to better understand, we'll just take this as an example. Okay. So what do you think can be used here to solve this question? So since we have to track, once we delete this element, we also to track the older elements also. So the best data structure will be to use a stack. Okay, let's see how we use stack to solve this question. So first let us take a stack. Okay, we will traverse from left to right. Whenever we see a element, right, whenever we see a element, then we will check whether the top of the stack is same as this. Okay, if a stack is empty or if the stack top is not same as this, then we will push this element as a tuple. So we will push D along with its count of occurrence. So by default, one will be our count of occurrence. Okay, now we move to the next element. So we check whether the stack is empty or whether the stack is not equal to E, top is not equal to E. So D is not equal to E. So our condition satisfied. Then we will push the element E along with the count of 1. Okay. Now again we move to the next element. Now we will check whether the stack is empty or stack's top is equal to E. So stack's top is equal to E. So what we will do, we will just increment the top count. Okay. Now we move, once we increment the top count, we will check whether the top count is equal to K or not. So 2 is not equal to K. So we will not do anything. Okay, will not do anything. We will do one more thing. For now, for simplicity, we'll just keep adding records here itself, but we will increment the count. Okay, so again we move. Now the stack's top is equal to again our current element. We will insert one more record in which we'll be adding the previous count and we'll be storing it here. Okay, then we will see whether the current top count is equal to K or not. So in this case it is equal to K, which is 3. So now we will pop 3 elements from the stack. Okay, now we will pop 3 elements from the stack. Let me pop all the 3 elements. So once we do that, we can continue with our loop. So now we encounter D. We already have a 3 D here. So we will append one more D. But the count this time we will be using this previous count and we will adding one more to that. Okay, now we move to the next element. Now the B appears. So B is appearing for the first time. It's not equal to the top element. So we will add B here. Now one more B is coming. So we will add one more B. Okay, with the count 1 plus the previous count. Okay, now we move to the next element. C is appearing for the first time, so we will add C here with the count 1. Okay, now again C is appearing. We'll add one more C with the count 2. And again C is appearing. We'll add one more C with the count 3. So in each iteration we will be checking whether the count value is equal to the k. This time the count value became equal to the k. Whenever this happens, we will be popping the first k elements. Okay, let me pop the first k elements. Okay, we popped the first k elements. We were here. Okay, now we move to the next element. Now b is appearing, so we will check b. Again, top of the stack is matching with b. Now while adding b, we will be using the previous count and adding +1 to that, right? Then we'll get 3. Again, now 3 is equal to the k value, so we will be popping next 3 elements. These 3 we will be popping them out. Okay, let me pop. Similarly, we will be repeating for the other elements as well. So now we get a D. Now the D is matching with the top of the stack. We'll append one more D with the incremented count from the previous value. Now again the count value matches with the K. So we'll be popping them out. So now we'll move to the next element, which is A. Now the stack is empty, so we will add A with the count of 1. Okay. Now again we reach one to the next element. Again the A is not appearing for the first time, so we will reuse the count here +1, which will become 2. Now we reach the end of the string. So we will pop every element from the stack, and we will construct the string and we will return it. So we pop this element. So join this element and return it. This should come first and this should come second. So you can either pop it and construct a string array or something and reverse it, or you can, if you are using Python, then directly join this element this way, then return this as the result. So this is the algorithm. Let's go to the coding part. So I'll be using Python. Okay, so to solve this question, we need a stack. Let me initialize S as a stack, and for each element in the string, so let me keep st as the stack. For each element in the string, we will check whether if stack is not empty, or let me check not empty, right? Okay, if it is empty or stacks. So remember, we will be having 2 elements in the stack. So we are seeing the 0th element should not be equal to the current element. So in this case, we can directly append the value with the count as 1. Okay, we will append this x with the count as 1. Let me use this. Else if this condition is not satisfied, then that means the top of the stack is matching with the current value. So what we have to do, we have to append with the count 1 plus the top of the stack. So top of the stack is this one, right? So the not in the 0th index is our character, but in the first index we have the count. So we use the old count and we add 1 to it and we store it. Okay, now it's time to check whether the count is matching to the k or not. If the count, this is the top of the stack's count is equal to k, then we have to remove the first k elements. So I'll be using slicing operation and I'll be removing the first k elements. Okay, whatever first k elements were there, I will be removing them. Okay, so we will be using no, in the stack we have to remove from the end, right? So whatever last k elements are there, I'll be removing them. Okay, now our iteration is completed. Now whatever remaining elements are there, we will join them and we will be returning them. For elements in stack, we will keep one result variable here. Okay, for elements in stack, we will be adding them. So remember, in the 0th index only we have the character. We will return. Okay, yeah. So this is the code. So let's try to run it. I have used yes instead of st stack. So let me correct them. Okay, let's try to run it now. Okay, looks fine. Let me try to submit it. Yeah, the code works fine. Yeah, thanks for watching, guys. So one more thing, earlier I was telling we can use only one insertion per character, right? Instead of inserting for each character, so we can just increment the count in place. So let's try to make the changes to optimize this. So first let's remove this append step and we will replace it with incrementing it in place. So I'll be incrementing the counter to in place. So counter is available in the index 1. Then after the incrementing, we should be able to pop in only once, because we'll be inserting incrementing in the same variable. And once this is done, I think while computing the result also, we have to multiply the character with the count. Okay, since we are storing it in one place. So let's try to run this with the example. Okay, it works fine. Just let's try to submit this. Okay, now it's working really good. So thanks for watching. See you in the next video. So this is the code. Thank you.